At Halswell Quarry, the floor really is lava. For 150 years, Halswell Quarry provided building materials for the city of Christchurch, but its history goes back millions of years beyond that.
The quarry is a small outcrop on the eroded flank of the Littleton volcano, one of the two major volcanic complexes that make up Banks Peninsula. Banks Peninsula as we know it began with the eruption of the Littleton volcano around 11 million years ago. It took about a million years to build up a large shield volcano, which probably looked a bit like Rangitoto does now. The volcanic activity moved southeast, first to Mount Herbert and then to the much bigger Akaroa volcano, around 9 million years ago. The final phase of volcanism on Banks Peninsula was called the Diamond Harbour Group volcanics. This consisted of much smaller eruptions on the flanks of Littleton volcano and inside the crater. Halswell Quarry started out as a volcanic blister that formed on the side of Littleton volcano but never broke the surface. It formed when new magma pushed up through cracks in the old volcanic rock in what's called a dike. The magma pushed through the flank of the Littleton volcano, deforming the surface, making a cryptodome. To see what it might have looked like, here's a time-lapse of a dome forming on Mount St Helens from 2004 to 2007. The lava stayed in place, and as it cooled, it contracted and fractured, creating the Halswell Bluestone that the early builders of Christchurch made such good use of. The Halswell Bluestone is a type of Hawaiite, thick, viscous, alkaline lava typical of late-stage volcanics. It contains tiny crystals of olivine or pyroxene, silicate minerals that crystallized before the lava had solidified. Today, around the quarry rim walk, as well as the Bluestone, you can see columnar basalt, which is about 9 million years old. It came from an eruption that filled in a valley on the side of Littleton. On top of it is scoria and ash that fell a bit later. Until 1860, the quarry was a huge bulge on the landscape. Over 150 years, most of the Bluestone was quarried, going into some of Christchurch's most recognisable buildings, but a lot was crushed and used as base course for roads and the runway at Christchurch Airport. Many early Christchurch landmarks, like the Canterbury Provincial Council buildings, were built with Halswell stone, although a lot were damaged or destroyed in the 2011 earthquakes. The Christchurch Arts Centre, formerly Canterbury College, was built with Port Hills basalt, similar to Halswell basalt. In the late 19th century, Canterbury College was home to Ernest Rutherford, sometimes called the father of nuclear physics. Rutherford studied radioactive elements, discovered the idea of radioactive half-life, and worked out how to estimate the age of rocks by measuring tiny quantities of radioactive decay products in them. Most volcanic rocks contain the radioactive isotope potassium-40, which decays into argon-40. When magma is liquid, the argon gas can diffuse out, but once the rock solidifies, the argon is trapped. By measuring how much argon is trapped in the rock, we can work out when it's solidified. Thanks to the work of Rutherford and many who followed him, we know that these Halswell rocks came from a bubble of lava that formed 6,930,000 years ago.
Today, we can walk round this outcrop, enjoy the view, and remember the history contained in this simple grey rock. From some of Christchurch's most beautiful buildings to the very origins of the land that we walk on.